Hey there, focused learners, and welcome back. Today's explainer is literally all about leveling up your daily workflow. If you've already got the basics of Docker down, but you're kind of looking to cross that threshold into running a highly optimized, completely secure, and just blazing fast containerized environment, well, you are in the right place. We've got some absolutely great material to cover today. Let's take these source concepts and transform them into actionable pro tips you can use right away.
Okay, let's dive right into this roadmap. First up, we'll do some spring cleaning on your Docker setup. Then we'll look at getting faster, optimized image builds. After that, we're covering security and resource limits. Fourth, we'll use containers as admin tools. And finally, we'll wrap up with containerized development environments.
All right, let's kick things off with part one, spring cleaning your Docker. So tell me if this sounds familiar. You look at your hard drive storage and just wonder, where on earth did all my free space go? Well, honestly, the answer might just be Docker. You see, in environments where you're frequently building and updating images, things just kind of accumulate over time. Every time you build a new image using an existing tag, Docker actually keeps the old image around. It just strips its tag. This creates what we call a dangling image. Now, combine those dangling images with a bunch of abandoned stopped containers, and suddenly you've got gigabytes of wasted space just sitting there doing absolutely nothing. But hey, here is your fix. These commands right here are exactly what you need to reclaim that space. You can run those prune commands with the -F or force flags to just wipe out those dangling images and stopped containers without it nagging you for permission every single time. But wait, really quickly, I need you to pay super close attention to that very last bullet point, Docker volume prune. Remember, volumes hold your persistent data, your mission-critical stuff. If you run this, it irreversibly deletes all local volumes that aren't currently attached to a container. It is a one-way street, folks, so please absolutely handle that specific command with extreme care.
Moving right along to part two, faster, optimized image builds.
Okay, there is really nothing worse than changing one tiny little line of code and then having to wait agonizingly long for your whole image to rebuild, right? Well, the secret to fixing this completely lies in Docker's layer caching. Basically, every logical line in your Docker file creates a new layer. Now, Docker is smart. It'll reuse these layers from previous builds if nothing in them has changed. But, and this is a huge but, if you change something early on in the Docker file, you bust the cache. And that forces Docker to rebuild that specific layer, plus every single layer that comes after it, totally from scratch. Now, what's really interesting about this slide is the fatal flaw hiding right in plain sight. This is a pretty typical, but highly unoptimized Node.js Docker file. Take a look at line 3, copy dot dot. This copies your entire source code into the image all at once. And then immediately after on line 4, it runs the notoriously slow npm install command. So what's the problem? Well, if you update a simple README file or tweak just one line of JavaScript, line 3 registers a change. Boom, the cache is busted. Now Docker has to run that heavy, expensive npm install all over again. So let's look at the pro way to handle this. See the difference here? On line 3, we are only copying the package.json files. And since your dependency list actually rarely changes day to day, this layer stays perfectly cached almost every time you build. Which means line 4, that heavy npm install layer, also stays fully cached. We don't even copy the rest of the source code until down on line 5. By just doing a simple reorder of these steps, your build times literally drop from minutes down to just fractions of a second. It's a total game changer. And to squeeze even more speed out of your builds, you absolutely need a .docker ignore file. Think of it exactly like a .getignore file. It tells Docker to completely ignore specific files and folders when sending your local context over to the Docker daemon. So by ignoring heavy stuff like log files, temp directories, or even sensitive .env files, you drastically shrink that initial payload. This speeds up the build process significantly and, as a bonus, ensures you don't accidentally bake private security keys right into your final image. All right, let's pivot to part 3, security and resource limits. Have you ever had a situation where one single runaway container crashed your entire host machine because it just gobbled up all the RAM? Yeah, it's the worst. But we can prevent that using Linux C groups or control groups. Think of your system like a super busy apartment building. C groups act like the building manager. They make sure that one noisy neighbor playing loud music, or in our world, a container hoarding all the CPU and memory, doesn't ruin the experience for everyone else in the building. It just guarantees a fair, safe distribution of resources. Let's look at the visual proof of this actually in action.
Check out the container here, which is currently under a simulated stress test using memory allocation blocks. If we direct our attention to the mem usage over limit column, you'll see we actually passed a memory limit flag when we started this container, putting a hard cap on it at exactly 512 megabytes. Even under heavy stress, desperately trying to consume more memory, the groups step right in. The container pushes right up to the edge, but absolutely cannot exceed that 512 limit. Your host system, it remains perfectly safe and perfectly stable. Now, shifting to privileges. The absolutely crucial point here is this. Most business applications running inside containers just do not need root access. They just don't. Yet, out of the box, Docker defaults to running containers as root. So if a hacker manages to exploit your app, bam, they suddenly have root-level power. The absolute best practice is to drop those privileges. By simply running your container as a non-root user, like by using the --user nobody flag, you heavily restrict what it can do. If an attacker tries to touch critical system files, they're just going to get a permission denied error. It is a massive security win for practically zero effort. Another incredible security tool we need to talk about is Docker Scout. Picture this. You pull an older base image for a project. Let's say Python 3.8.14. You decide to run a quick vulnerability scan, and suddenly your screen just lights up red. Docker Scout has found 8 vulnerabilities lurking in those packages, and terrifyingly, 3 of them are labeled high or critical. We're talking path reversal and code injection vulnerabilities here. You definitely do not want this shipping to your production environment. Fortunately, the fix for this is usually incredibly simple. You just pop open your Docker file, update that base image to a newer, patched version, say Python 3.14 Slim, and you rebuild. Run Docker Scout one more time, and boom! Look at that beautiful, clean scan. 0 critical or high vulnerabilities. By just making it a regular habit to scan and update, you keep your applications totally shielded from newly discovered exploits. Okay, moving on to part 4. Containers as admin tools. This is like a true development superpower. So, imagine you download this really handy Perl script, but you don't actually have Perl installed on your laptop. Do you go and clutter up your host machine by installing it? Absolutely not. You use Docker. You just navigate to your folder, spin up a lightweight Perl container, map your local folder right into the container using a volume mount, and execute the script. The absolute magic here is the --rm flag. The very second that script finishes executing, the container completely deletes itself. Your script gets run, and there is 0 trace of Perl left on your host machine. It is so perfectly clean. And this brilliantly illustrates a really important concept for when you want a container to actually perform Docker tasks, like maybe in a CI/CD pipeline. You basically have 2 options, but one is vastly superior. Option 1, you can mount the host's Docker socket into the container. This lets a lightweight command line interface inside the container securely control the robust Docker engine that's already running safely on your host. Compare that to option 2, Docker in Docker, or DIND, where you actually run a fully nested engine inside the container itself. DIND is generally highly discouraged. Why? Because it introduces massive security risks and serious performance overhead. So stick to mounting the socket, just, do so cautiously. Finally, let's wrap up with part 5, containerized development environments. We are finally curing the dreaded, well, it works on my machine syndrome. By pairing VS Code with Docker, you can literally move your entire development backend directly into a container. It's so easy. You just install the remote development extension pack, pop open the command palette, and tell VS Code to open your folder inside a container. It seamlessly bridges your local editor with a perfectly isolated Docker backend. What's wild is that you can literally boot up your entire workspace beast directly on your project's existing Docker file. With just a single click, VS Code reads your Docker file, builds the image with the exact correct versions of Java, Node, Python, or whatever it is you need, and drops your IDE right inside of it. And what is truly amazing here is that the user interface stays crisp and fast right on your local laptop, but all the actual heavy lifting is happening safely inside the dev container. Just look at this extensions panel right here. Things like the Java debugger and Maven, they're installed remotely inside the container, not on your actual host machine. Your laptop stays perfectly clean and uncluttered. The benefits of setting things up this way are just massive. First, you get complete environment isolation, which means absolutely no more version conflicts between your different projects. You also get perfect consistency, meaning every single developer on your team is booting up the exact same environment. Plus, you can safely experiment with some crazy new language framework without cluttering up your system. And hey, if you work in a corporate environment that strictly locks down local software installations, Dev containers let you bypass that friction entirely since everything runs safely containerized. Well, we have covered a whole lot of ground today, from clearing out gigabytes of digital waste to optimizing our build layers so they run at lightning speed, locking down those system limits, utilizing throwaway containers for admin tasks, and finally, completely revolutionizing our workspace with dev containers. So the only question left for you is, which of these pro tips are you going to implement in your workflow right now? I highly encourage you to open up that terminal right now and just start experimenting. Thanks so much for joining me on this Explainer Focus Learners, and I'll see you in the next one.